Hello everyone, let's take a look at this Cambridge Assessment Examination. This is the Chemistry AS and A level paper. Question 1. In this question, Q is used to represent a halogen atom. Magnesium and calcium each form a compound with chlorine and a compound with bromine. One of these compounds contains the element in group 2 with the higher first ionization energy and the element in group 17 with the higher QQ bond energy. What is the formula of this compound? So first thing I want to do is I want to write out the compounds. So magnesium is going to form a compound with chlorine and bromine. So magnesium is in group 2, and so it's going to have a charge of 2+. So Mg2+. And if it forms a compound with chlorine and bromine, chlorine is in group 7 or group 17, so it's going to have a charge of -1, and bromine is going to have a charge of -1 as well. So if I'm going to join these, I'm going to get MgCl2 and I'm going to get MgBr2. Now if I have to do the same thing for calcium, the calcium compounds I'm going to get are going to be CaCl2, since calcium and magnesium are in the same group. So the charges will be the same, and so the only thing we're changing is the magnesium for the calcium. And here is going to be CaCl2, CaBr2. Okay, so these are my 4 options. So they say the element in group 2 with the higher first ionization energy. So we need to remember what is the trend for ionization energy. Ionization energy is the energy required to remove the outer electron, right, from an atom in the gaseous state. So what is the trend? So we know that ionization energy decreases as we go down a group. So if we have to look at it, it decreases as we go down. So calcium is going to have a lower ionization energy than magnesium because calcium has an extra orbital. And so it's not going to experience that same force of attraction from the nucleus as an electron of that's sitting on an atom of magnesium, right? So in this case, we're going to say that magnesium has a higher first ionization energy. So we are looking at these options here. The next one is the element in group 17 with the higher QQ bond energy. So which one is going to have the higher energy? So is it going to be Cl or Br? So bond energy is dependent on the electronegativity here. So electronegativity increases to the right and it also increases up. So chlorine is actually going to have a greater electronegativity. And so the atoms are going to be quite tightly bonded, right? So the answer then is going to be A. So let's just circle it in. So the answer here is A. So this one, Mg, and this one was Cl. Okay, question number 2. Compound X contains 2 elements, Y and Z. Okay. Element Y is in period 2 of the periodic table. In one atom of element Y, the p subshell has all 3 orbitals occupied. Only one of these 3 orbitals is fully occupied. Okay, so since it's in period 2, it's going to be 2. Then it has p subshells, so p. And then all the p subshells are occupied and only one is fully occupied. So that's basically saying that it has 4 electrons. So 2p4, right? So Y is the element that has 2p4. Then we're looking at Z. Z is in period 3 of the periodic table. Okay, so it's going to be 3. In one atom of Z, the p subshell has only 2 orbitals occupied. So 3p2. So we want to figure out what's going to be sitting in 2p4. So 2, so this is 2, and then p4 is oxygen. So this is oxygen. And then 3p2 Here's 3p1, 3p2. That's 3s1, 3s2. That's 3p1, 3p2. So silicon. So what kind of compound are we going to make with this? So this is going to be SiO2. And so the answer here is going to be C. Now moving on. Question number 3. Globus salt consists of crystals of hydrated sodium sulfate, which can be used for the manufacture of detergents. When a sample of globus salt was heated, 1.91 grams of water was removed, leaving 1.51 grams of anhydrous Na2SO4. What is the value of X? Okay, so what we need to do is we need to work out number of moles. So we'll do number of moles for the salt, and then we'll do the number of moles for water. So number of moles is mass divided by molar mass. The mass of the salt is 1.51 divided by the molar mass. Now to get the molar mass of this compound, it's going to be 23 plus 23 plus sulfur is 32 plus 4 times 16. And so the total here I think is 142. And if you work out the number of moles, it's going to be 0.01. Now the number of moles for water is going to be 1.91 divided by 18, which is 0.1. Now you look at the ratio. The ratio of the salt to water is 0.01 to 0.1. So you divide by the smallest number, and so you'll get 1 to 10. So the answer then is going to be C. Okay, let's move on. Let's take a look at question 4. What contains the greatest number of named particles? So here we're looking at the equation N is equal to N over Na. So Avogadro's constant. Now we don't have to do the whole calculation here, because remember, we can look at a proportionality here. The compound or the particle that has the greatest number of moles is going to have the greatest number of particles, because N is directly proportional to capital N and Na is constant. If you wanted, you could even rewrite it. You could say N is equal to N times Na. That's a constant, so we don't need to worry about that. The greater the number of moles, the greater the number of particles. So all we need to do for these options is to calculate the number of moles. And the one with the greatest number of moles will be the one with the greatest number of particles. So for the first one, 6 dm cubed of argon atoms at room condition. So that's gas. So we need to use the gas formula. So N is equal to V divided by Vm. 6 divided by the molar gas volume at room temperature is 24. So 6 divided by 24 is 0.25. Then carbon, that's grams. So we can use the molar mass formula. So N is equal to 6 divided by 12, which is 0. Oh, carbon dioxide, excuse me. So carbon dioxide is not 12. So number of moles is equal to 6 divided by, carbon dioxide has a molar mass of 12 plus 2 times 16. So that's 44. So 6 divided by 44 is 0.14. Then magnesium, number of moles is equal to 6 divided by 24. The molar mass of magnesium is 24, and that is 0.25. Then the last one, water. Number of moles is equal to 6 divided by 18, and that's equal to 0.33. This has the greatest number of moles, and so it's going to have the greatest number of particles. So the answer is D. Let's move on. Question number 5. Phosphorus forms a compound with hydrogen called phosphine, pH 3. This compound can react with a hydrogen ion, H+. What type of interaction occurs between pH 3 and H+? So this is going to be a dative covalent bond. And why is it a dative covalent bond? Because you have pH 3, right? And there is a lone pair on the phosphorus that can form a bond with a hydrogen ion like this. And that bond, since the hydrogen is not bringing any electrons, that is called a dative covalent bond. So that answer is A. Let's move on. Question number 6. The graphs show The graphs show trends in 4 physical properties of elements in period 3, excluding argon, which graph has electronegativity on the y-axis. So if we're looking at the trend for electronegativity, we know that electronegativity increases as you go to the right. So the graph that's showing a steady increase as you go to the right within the same period is D. Okay, let's move on. Question 7. The element tin exists in 2 forms, gray tin and white tin. Some properties of gray tin and white tin are shown. Okay, so we can see the boiling point. So white tin has a greater boiling point. Okay, electrical conductivity. So white tin is a good electrical conductor in solid and liquids. And malleable, gray tin is very brittle while white tin is very malleable. So which structural change might take place when gray tin changes to white tin? So giant covalent to giant ionic, giant covalent to giant metallic, giant ionic to giant covalent, and indeed giant ionic to giant metallic. So if we're looking at these properties now, right? So we can see the first one, it has a high boiling point. So high boiling point is generally a property of ionic / metallic, right? Compared to covalent. Covalent will have the lower boiling point. Then electronegativity, it's more electronegative in white. So white tin is more electronegative. That's a property of ionic or metallic. And then the last one is malleable, right? And malleability is a property of things that are metallic. And so we can see that it's metallic throughout. So the change is going to be something to giant metallic. So our options are either B or D. Now, you can see that malleability is quite brittle. So brittle is a clue to tell us that it's going to be covalent. So B is going to be, the answer is going to be B, giant covalent to giant metallic. Let's move on to question number 8. Which solid has a simple molecular lattice? Okay, A, calcium fluoride. So calcium fluoride, CaF2, this is an ionic lattice because it's an ionic compound, right? So A is out. Nickel, so if you look at nickel, nickel is a metal, and so it's going to have a metallic lattice or metallic lattice. So the B is out. If you look at C and D, so C is sulfur dioxide or sulfur oxide. Silicon oxide. I misread that. Silicon oxide, right? Now, silicon oxide is not discrete. It is actually a covalent lattice, right? It is not discrete. And what do I mean by not discrete? I mean that you can't identify individual SiO2 molecules. Because any silicon oxide structure, you have one silicon that's bonded to 4 oxygen, and then the oxygen is then bonded to silicons. And you can't then identify individual molecules because it forms a giant lattice. So C is going to be out. And the last one is sulfur. So sulfur forms a simple molecular lattice. And why? Because sulfur has weak van der Waals forces. So the answer here is going to be D. Question 9 reads, the standard enthalpy change of combustion of carbon is minus 394 kilojoules per mole. So let's write that down. I'm going to call it reaction 1. So C plus O2 gives me CO2, and that's minus 394 kilojoules per mole. Then reaction 2, the standard enthalpy change of combustion for hydrogen. So H2 plus half O2 gives me H2O, and that's minus 286. Then reaction 3, the standard enthalpy change of formation of butane. So 4C plus 5H2 gives you C4H10, and that is minus 129. The question wants to know, what is the standard enthalpy change of formation of butane, combustion of butane? So combustion of butane is going to be C4H10 plus O2 gives you CO2 plus H2O. Now, there's a few ways that you can do this. For example, Hess's law. Though I'm going to do a different way. I'm going to use the reactions that we've just written up, and I'm going to switch them around to get the reaction that we want and get the standard enthalpy. So first thing I'm going to do is I'm going to write down reaction 3. I'm going to write it in reverse. So C4H10 gives you 4C plus 5H2. And since I've reversed it, I'm going to reverse the enthalpy, so that's going to be 129. Now I want to cancel this carbon because I don't want carbon in my final reaction. So I'm going to join it with reaction 1. So reaction 1 is C plus O2 gives me CO2. And that's minus 394. Now how do I cancel the carbons? I can cancel the carbons because they are on opposite sides of the reaction. One is on the reactant side, one is on the product side, but they're not equal to each other. So I need to multiply one whole reaction by 4. So I'll multiply this by 4, that by 4, that by 4, and also the enthalpy by 4. Now, this will cancel with that, and I'm going to have C4H10 plus 4O2 giving me 5H2 plus 4CO2. And now my enthalpy, I just add this up. I'm going to get minus 1447. Now I need to cancel the H2 because in my reaction that I want, there's no H2 on the product side. So I'm going to join this with reaction 2. So H2 plus half O2 gives you H2O, and the enthalpy is minus 286. Now the H2s won't cancel unless I multiply the second reaction by 5. So everything by 5, including the enthalpy. Now the H2 will cancel, and I can bring everything down. So I'm going to have C4H10, then 4 plus 5 over 2 is 13 over 2. So 13 over 2 O2 gives me 4 CO2 plus 5 H2O. And if I add up this enthalpies here, I'm going to get minus 2877. And you can see that that matches up with B. Now let's take a look at the last question, question number 10. They want to know 3 processes are described. 1, 2, 3, which statement is correct? So they want to know none of the processes have a positive enthalpy. Only process 1 has a positive enthalpy, process 2 or process 3. So if I look at the first one, H plus OH minus is H2O. That is a neutralization reaction. And neutralization reactions are exothermic, meaning heat is given off, energy is given off. Right? So that delta H is less than 0. It's negative. Number 2, CH4 plus O2. That is combustion. And we know that combustion is exothermic. The delta H is less than 0. Question number 3, NH3 gas goes to NH3 liquid. So what's going on here? This is a phase change, right? But the phase change is from a higher energy level, higher energy state, to a lower energy state. And so when this compound changes from a gas to a liquid, energy is going to be given off because it has a lot of energy. So energy is given off. Given off. And if energy is given off, that means it's exothermic. The delta H will be less than 0. And so all of them are exothermic. So the answer here is going to be A. Okay, I'm going to stop here, everyone. Thanks so much for watching. If you like this, don't forget to share and subscribe. I'll see you in the next one. Bye-bye.